Normally, we are in charge of nearly about 30 people working under me. Yeah. Okay. We normally we schedule the lighthouse into different groups. Some are the major A's, some are the minor A's. For the major A's, we usually visit this lighthouse or beacon maybe 2 months by Monday. And some, for the more minor one, we visit it quarterly or half yearly. Yeah. Because this lantern will be just a you can see they have different color, maybe as red, green, and white, yellow, something like that. This lantern, for different circumstances, it suits different purpose. So it depends on different location. We use different kind of lantern, something like that. Even though the ships are different, but the purpose is the same. The purpose is to draw the attention of the mariner when they come to the port of Hong Kong. They will see within a certain luminous range, the mariner can see the lighthouse, and then you can identify that lighthouse will be referring to which location. So no matter this different kind of form of lantern, this purpose is to draw the attention and to give warning to the mariner only. Yeah. Normally, we have this marina will get the handbooks. Inside the handbooks is different location. In Hong Kong, this called the Emergency of Lights. Under this handbook, the marina will know when you see the different characters of that lighthouse, the different color, they will identify themselves in which location. Yeah. During all the years from the gas lantern, because the gas lantern is more dangerous for the operator and ourselves. So when the technology is mature, nowadays we change from the gas operated lantern into electric lamps. And then because of the mature technology from the solar power operated lantern, so nowadays over 90% of our lighthouse and light beacon has been changed to solar power operated lantern already. Yeah. Because from the old days, the gas lantern will get the acetylene gas. It's quite heavy to carry. But nowadays, we change to solar operated lantern. So the carrying of this heavy kind of equipment, this storage battery has been minimized already. So to get the same kind of manpower, we can more productive in this technology. Yeah. The technology has been changed into different phases. For the first time, from gas lantern to electric lantern, and nowadays from electric lantern to LED lantern. So we get 3 phases of changes from gas lantern, electric lamp, and the LED lamp nowadays. Yeah.
隔離嗰支咧就係 Emergency Wreck Buoy， 即係沉船抱用嘅燈。呢個牌咧就 HPS S01，HPS 係我哋嘅 Harbour Patrol Section 海港巡邏組嘅。呢個成個鋪咧係屬於佢哋嘅，只不過我哋呢一組別咧 ANMU 咧副航設備及系鋪小組咧就提供個技術支援。咁佢個鋪翻嚟咧，就需要我哋就維修啊，或者去整理啊，咁都嚟到我哋呢個工場度做呢樣嘅工作嘅。呢個咧就係當佢哋巡邏組咧同事接到有沉船嘅報告啊，或者有啲即係喺海底裏邊有啲沉積嘅物件嘅時候咧，佢就會放個泡喺個海裏邊嘅，咁提醒咧船，呢度有啲即係沉船嘅物體，咁使到啲船隻咧就唔需要撞埋嗰度產生第2單嘅沉船意外嘅，係。咁睇 HPS 佢清咗嗰個沉船未？如果個沉船物體未清咧，就佢都會繼續放嘅。 咁直至到嗰個沉船物體被移走咧，咁佢個泡就會被移走，又或者個泡本身咧有損毀啊，或者啲燈唔着啊，或者其他方面爛咗咧，佢亦都會將新嘅沉船泡咧就放翻喺個位置，舊嘅就俾我哋去維修咯，嚇。你會見到支燈咯，咁佢呢個係雷達反射器咯，呢、個泡身咯，呢、個係屬於係即係ballast嗰類係固定去，咁使到個泡咧喺咁上下呢個位置度浮沉咯，就波日時嘅我哋做呢個浮力嘅呢，佢嘅重量咧就因為唔係太過重，好應該就20個 kg 咁上下，因此咧就方便即係啲員工做嘢，將佢放落海啊，或者甚至喺海上面抽翻上嚟。呢、個係特別嘅設計啊，俾 HPS 呢個海港巡邏組嘅同事。呢、個光亮咧應該係3海里嘅，3海里嘅。喺夜晚黑嚟講咧，佢可以照射3海里嘅。因此咁遠嘅距離嘅時候咧，船相信都唔會撞埋去產生意外啦。呢、個因為佢雷達，當有電波彈落去嘅時候咧，當有3 wave 彈落去嘅時候咧，佢就彈翻過去啦。所以佢設計方面咧係我哋接收雷達嘅信號啊咁樣啊。如果你普通一支柱咧就非常之弱，佢呢個加強咗佢即係回聲嘅設計，即係接收方面會強好多，會喺佢雷達嗰、個顯示屏嗰度咧會見到佢有一點嘅，會好清晰嘅咁。
Okay, well, behind me, what we've got is a lovely piece of history that's nearly as old as I am. I think it probably came to Hong Kong sometime in the early 1950s, and it served right the way through until the 1980s. But it's actually of a much, much older design. The design itself perhaps goes back to the very beginning of the 20th century, and someone who is almost a god in lighthouse circles called Gustav Dalén. He was a Swede from Sweden, a Swedish man, and he pioneered so many major innovations in lighthouse technology to ensure, in his own word, that the light never went out, that he got the Nobel Prize for Physics in, I think, 1908 or 1909. The light here that we see is a gas lantern, and gas was, acetylene gas particularly, was really Dalén's great claim to fame. He's the man who made acetylene relatively safe by developing a way of liquefying it so that you could transport it safely. It's always difficult, very dangerous to transport gas. He turned acetylene into a liquid which would gasify when it came out from pressure. The gas then lit a mantle. Now, gas mantles were something developed in the 19th century where you have a silk net and you soak the silk net in lime, calcium carbonate, I think. It's then faintly stiff, and if you then light a flame inside the mantle, the lime that's soaked into the silk becomes incandescent and it burns with a brilliant white light. So with his acetylene gas and a mantle, he created a very reliable, very bright source of light that could be switched on and off. And this was his second great invention. It was the sun valve, and it was a very simple, brilliant piece of conceptualization. He knew that subject to heat, light, metals expand at different rates depending on how much heat they absorb. So he created a very simple valve using 4 pillars of copper covered in gold foil. Later they just used chrome. In the middle was a pillar, slightly larger, painted black. They used what's called lamp black, very, very dense black. And this pillar of black had a spring attached to it, but it pressed on a plate that had a pin that opened and closed a valve for gas. When it became daylight, the black pillar absorbed light and expanded. Didn't expand very much, just expanded a little bit, but enough to push the plate down and close the valve. As soon as the sun went down, the light disappeared, the black pillar contracted because it got cool, and it opened the valve. The gas flowed, the light came on. So for the first time, you had a light that would switch itself on and turn itself off with gas. And it was so reliable, this light, when it was designed in 1907, that it continued in use all over the world until the 1980s or 90s. In fact, there are some places around the world that are still using gas lights like this one because it's so reliable. But in Hong Kong, there was a push to modernize, to try and reduce the costs in manpower. The chief of the light section here was telling me that when this was in commission, with its gas lantern, every 2 months they had to go out and change the mantle, because after use the mantle begins to get less bright, and it also accumulates soot. The burner accumulated soot, and you can see on top of it there's a chimney, because of course this is a flame and it's creating heat, and you've got to get rid of that heat. So you have a chimney stuck on top of the light, and the chimney would also accumulate soot. And if they allowed the soot to accumulate, it would then, when it blew hard, the soot would shake off into the lantern and the light would get dimmer, and you couldn't have that. So they were very high maintenance, which means you had a lot of people, and people are expensive. And so Hong Kong needed to electrify. So in the 1980s, this was on the 9-pin islands, which are out in the southeast corner of Hong Kong. This was taken off and brought here. Originally, it had a sun valve with it, but the sun valve has sadly disappeared, I hope, to the Museum of History, so it's not here for us to look at. You can see the structure of it. On the outside, you've got these trapezoidal curved panels of armored glass. That's the light's protection. And you can see it's broken into panels for the very simple reason that in really, really bad weather, if something breaks, only one panel will break. The others will stay intact. It also makes it easy to replace. If you break a panel, it also makes it easier to make if it's in several segments. So that's this, and if you look very closely, you'll see behind each junction is a very thick web. So this is a very strong structure that contains the lens. In behind it, you see that absolutely beautiful Fresnel lens with its prisms. And there, this is a 6th order lens. They come in orders starting with super hyper radial, then there's radial, then there's 1st order, 2nd order, 3rd order. The biggest lenses are as tall as that roof up there and weigh maybe 6 or 7 tons. This is a nice simple little 6th order lens, beautifully made of glass, but it's a very, very, very precision instrument. When that's installed, if you look closely, each bit of glass in that is a separate bit of glass. And it sits in, I suspect that's aluminium, a black aluminium frame, and each piece of glass is set into the frame, and the hole has got to be so precise that when the light is lit, all of the light rays pass through the lens exactly where they must to get a parallel magnified light shining exactly level out of the light to the point on the horizon where the light is meant to be seen. And that can take days to focus a lighthouse light to get this absolutely right. It's very high quality optical glass. It's a very, very expensive piece of equipment. The wonderful thing about this light, though, is that if you look closely at the base, just here, there's a sign. And the sign says AGA, acetylene gas, Aktiengesellschaft. It was Gustav Dahlen's own company. And it stayed in business from the late 19th century right the way through until the 1960s, when it was taken over by a British company called AB Faros, who are still in business. They still sell Hong Kong Marine Department lights for their lighthouses. And this is a direct descendant then of one of the pioneers of high quality lighthouse optics and technology for lights. And here it is, a lovely remnant. You can still see most of what it was like. Unfortunately, the one thing it's missing is its original light apparatus. And in order to make it an attractive object in this area, an electric light has been put in it. But if you look, two things are quite interesting. First, the signal that the light is sending, which is 1, 2, 3, 4, 5, 6, long, off, is actually for a south cardinal, which would be disastrous in the north 9-pin, because you'd need a north cardinal for the north 9-pin, because it says, I am north of the problem, and the north 9-pin is the problem. So if you wanted to keep north, this is telling you to keep south, which would mean you just go bang, straight into the island. So it's not a well-chosen characteristic. The other thing, if you look, you'll see that the light is wrongly placed. The light itself should be right in the middle of the lens. You can see the lens has got a system of chevrons that come down like that and a single central lens area. The light should be right in the middle of the central lens area. Obviously, it was too difficult to do, so they didn't do it because it's just for decoration. But that would be another part of setting the light up. In order to make sure that it's shone properly, everything has to be in exactly the right place. It's a very, very high technology thing. It looks simple, but it's actually incredibly high tech. They have pretty much changed all of the design. First, the glass in the Fresnel lens has given away to molded plastic, because molded plastic is a bit more robust, not a great deal cheaper, but it's a bit more robust, and because it's coming out of a mold, it's already locked into its structure, and you don't have to spend a lot of time fitting bits of glass into a metal framework. So glass has given away to plastic. Gas has given away first to incandescent bulbs, and these days to LEDs. And that's created, interestingly, I noticed when we were in the workshop recently, it's actually gone backwards in light technology, because the latest light they've got, which is made out of LED displays, goes back to a system of lights which was last seen in the late 18th century, called a catoptric, which is just a reflector. So they've got a strip of LEDs and a parabolic reflector behind it, and they've got maybe 20 of these strips of LEDs, each one being reflected and magnified down a focal plane. And that's exactly what the earliest lighthouses in the 18th century looked like, that used optical apparatuses to improve the brightness of the light. And they don't have a lens at all. So we've gone from no lens through the complex world of lenses back to no lens and just a reflector. Whether that will stay, I don't know. It wasn't for, the one I saw wasn't for the most powerful lights, but the chief of the lighthouse service told me that they do make one that is good enough for the strongest lights, which can be seen 25 miles away.